Okay, derivatives of log functions. Really the one that is huge here that you have to know is this one because it'll show up all the time. Did you guys get notes yet? Okay, I'll get you some. This one here, I don't think I've seen on the AP test because if it was on the AP test, I would have to look it up because I never use it. This one here could definitely be on the AP test. It's not as common. And then this one, obviously, you should know, right? That one's a big one. Go ahead and do the first one. It should be really easy. You're using this one right here. Okay, so the first one here, take the derivative of natural log. So I just always remember that you do 1 over what's inside the parentheses. And then you have to take the derivative of what's inside. So what's the derivative? 3x squared. And a lot of people, they see this as you take the derivative of what's inside goes on top, and then the actual what's inside goes on bottom. Same thing, because this would just jump to the top. So you may have learned it that way. But that's what we end up with. Okay, this one, same idea. So we do 1 over sine, and then derivative of sine is what? Cosine. And what is cosine over sine equivalent to? Cotangent. Okay, what about the third one? What do we have to do? So we're going to treat this as natural log of x to the half power, and then take the derivative. So pull the half down, leave the natural log of x alone, and then it's to the negative a half. And then what's the derivative of the inside? 1 over x. And everything is in the denominator there, right? So I would probably rewrite that as a 1 over, what do we have, 2x, and then square root of natural log of x. Does that look okay to everyone? Okay, this one here, just follow the rule. Like I said, it's not something that I've seen a lot on the AP test, but it's good to practice these things. So that's log base a of x. You do 1 over the x, which is what's in back, and then you do natural log of the base. So let's do the derivative. So we're doing 1 over, what's my x here? 2 plus sine of x. And then times by natural log of a, which would be natural log of 10. And we'll just leave it like that. Oh, what did I miss? What do I need to multiply the back by? The derivative of the inside, right, which would be cosine. Don't forget your chain rule. Okay, now this one here, if you just jump into it, you're going to do it probably a really long way. So when you look at this problem, most people go, okay, it's natural log of something, so I do 1 over that entire thing. And then you multiply by the derivative of that entire thing by using quotient rule. It gets really, really, really messy. So I'm going to show you a different way to do it, and it's using law of logs. Now there's probably people who don't remember all the laws of logarithms, so let's write those down somewhere on your sheet of paper here. And this works for logs or natural logs, okay? So natural log 2. That's a little L. You might want to make it like that so you see it as natural log. Okay, so if I have log of a over b, what do I do with that? Subtract, right? So you split it into 2 logs, and then you subtract. Okay, if you have log of a times b, so something that's multiplied, we split the log and it becomes plus. And then the other one is if you have log of something to a power. What do you remember for the power? What do you do with it? Yeah, you bring it down front. And usually all it takes is just a quick review and we remember it. That doesn't mean you always remember to use it. And if you don't use it here, like I said, it just turns into a really long problem. You should still get the same answer. It might just take a little work to get it to look like the same answer. So what we can do here, we have natural log of something divided by something. So how can we split that up? Yeah, natural log of the top. And then subtract the natural log of the bottom. Can I do more with that if I want to? Yeah, you can bring the 1/2 power down in front, so let's just do that. I'm just writing it here because this is the first time we've done this in probably a while. But you could obviously do it in the same step. Is there anything else I can do if I want to? I can't do anything else with the function itself, right? But now I can take the derivative. We haven't done anything with derivative yet. So derivative of natural log of x plus 1 is 1 over x plus 1. And then I have minus 1/2. That constant can just stay out front. And the derivative of natural log of x minus 2 is 1 over x minus 2. Okay, and that is way easier to simplify to try to get it to match an answer. Sometimes you need to get a common denominator. Let's just do that because maybe we're not doing enough of that stuff. So what would be my common denominator here? So you're just multiplying it. Let's just leave it all factored. That's probably how your book will do it. And what do I need to multiply this first chunk by then? 2 and an x minus 2. So this first chunk, you're going to have a 2 and an x minus 2. And then we're subtracting. And what do I need to multiply this by to get the same denominator? X plus 1. And be careful that you have a negative there. And then you could distribute here and try to simplify. So 2x minus 4 minus x minus 1. And then the same denominator. And then combine like terms, so x minus 5 over that. And I can't cancel the x minus 5, so it should be good. Okay, way quicker that way than the other way. So questions on the laws of logarithms, because we're going to use them on the back here, and it's a BC concept, so. Huh? Oh, it's still in the front of yours. Yeah, it's on the back of mine, sorry. Okay, so steps in logarithmic differentiation. So logarithmic differentiation, you maybe saw it in AB last year. This might be something that's new to you. Okay, first step, take the natural log of both sides of an equation and then use the properties of logarithms to simplify. So your very first step is to put natural log in front of both of these. And then we're going to use the laws of logarithms to try to simplify. So the natural log of y is just going to stay natural log of y. What can I do with this piece first? Split it because we have division, right? So we're going to split it and make it the top and then minus the bottom. What can I do with the top also? Okay, so it's a multiply on top, so we can add those pieces. And then also the exponent can come down front. So I'm going to do all that in one step. And if you have questions, make sure you ask. So I'm going to pull the 3/4 down front. And have your attention, please. Oh, I forgot my natural log, of course. Will be meeting in the comments today. Will you read over here? Just watch it. It's going to push the That was quick. Okay, so this piece here turns into 3/4 natural log of x. This piece, the half will come down, and then I've got natural log of x squared plus 1. And then when it's in the denominator, make sure you have a minus there. The 5 makes its way down. And then I've got natural log of 3x plus 2. All of them should have a natural log with them, so double check that. So we did step 1 right away here. Step 2, differentiate implicitly with respect to x. So take the derivative with respect to x. So what's the derivative of natural log of y? with respect to x? dy dx. Okay, implicitly there, so don't forget your dy dx. Okay, the 3/4 will just stay out front of this. Natural log x is 1 over x. The half will stay out front. This will turn into so you do 1 over x squared plus 1, but then you have to remember to multiply by 2x. So I just put it in the numerator. It's up to you if you want to write it out back or in the numerator. And this one, the numerator or out back, we would have 3 and then the denominator. Okay, let me know if I messed anything up there. Does that look right? And then the only thing you have to do to get dy dx by itself is what? Divide by 1 over y or multiply by y. Okay, so I'm going to multiply everything by y here. And then I'm going to simplify some stuff on the other side. So I have dy dx equals 3 over 4x. And I'm just going to put the y out front here. But you could put it out back. It doesn't matter. Plus, here the 2's will cancel, so we just get x over x squared plus 1. And then minus 15 over 3x plus 2. We don't go crazy about simplifying this more because your book doesn't. The only other thing that you need to do is you don't want to have a y here. We're going to put this into its spot. So it's easy to do. It just looks real complex. Okay, y is equal to this here. So you put that into the y spot. And that's your last step. So solve the resulting equation for y prime. And then just remember, you might want to make yourself a note to plug the y value, or plug the equation for y back in. So questions at all? Okay, this one is more common for like an AP question. This just keeps it so it's a little more simplified because trying to take the derivative of that otherwise is kind of a mess. But you could do that one a different way on the top. This one here, when you have an x at the base and there's a square root of x in the exponent, it's kind of hard to see here. Hopefully you can see it on your paper. You have to use implicit in order to get that y in the exponent to come on down. So when you're doing your homework and you're like, oh, I've got an x up in the exponent and I can't take the derivative of that, you need to use the logarithmic differentiation to do that, okay? So you're going to take the natural log of both sides. When you do that, the square root of x will come on down. And then how do I take the derivative of this? Okay, so we get 1 over y dy dx, and then over here we have to use product rule, right? So let's leave the square root of x alone. Derivative of natural log x is 1 over x. Now leave the natural log x alone, and the derivative of x to the half is half x to the negative a half, or you can move it to the denominator right away if you want. And then I'm going to multiply by y here. And I'll plug it in the last step just so you can see what I did. What's this going to simplify to? One over square root of x. So practice combining that stuff. Okay, this is x to the 1, x to the half. So it'll combine to be a half in the bottom. And then plus natural log x on top, 2 square root of x on bottom. And then this might turn into a common denominator situation because it's really easy, but you don't have to here. And the y will turn into x squared of x. So this will be your answer. So questions at all? Don't try to simplify too much until you check the answers in the back, because sometimes it doesn't really require you to. If you're not getting the same answer and it's just a simplified form of it, try to get your answer to match their answer. It's good practice for those multiple choice, okay? So questions at all? Like I said, you might not have seen that before, so that one's a little bit new, but it's not crazy difficult. A lot of the BC stuff is like it's new, but it's not crazy difficult. You need to have a good A-B base in order to do it, though, okay? So you guys can start your homework there.